The table we created in the last video for Ashley's demand is what we call a demand schedule, and of course this would be Ashley's demand schedule for widgets. Another way to look at demand is if the demand has a specific mathematical functional form, we can actually look at the equation that represents that demand, and we can use that equation to graph the demand curve or manipulate the demand curve as we have policy changes. So how do we determine what function represents a demand curve? For Ashley, the task is quite simple. We can see that there is a constant rate of change between the quantity demanded and the price. So in particular here, we change the price in $400 increments from $2,000 down to $1,600, then down to $1,200, $800, $400, and zero. And you'll notice that's a constant $400 change. On the quantity side, as we decreased price, you'll notice that we increased the quantity that Ashley wanted to buy by $200. So each of these changes is $200 increments. So the change in quantity was constant at 200 units for every change in price, and the change in price was also constant at a change of $400. And of course you'll notice that these two things moved in opposite directions. When the price was high, Ashley wanted very few of this good. When the price decreased and got very low, Ashley wanted a lot more of this good. This relationship between high prices and low quantities, and low prices and high quantities, is what we call the law of demand. The law of demand just says that people like low prices. When the price is high, people want few of the good, and when the price is low, people want more of the good. This law of demand generally holds for most goods and for most people. Now back to the functional form of Ashley's demand. We had a constant change in price and a constant change in quantity demanded, so we know that this function is going to be a linear function. How do we know something is a linear function? Well, two things. First of all variables in the linear function are to the power of 1. And second of all, a linear function has a constant slope or a constant rate of change of one variable with respect to the other variable. In a linear demand function, the demand function becomes quantity is equal to some constant plus the change in quantity over the change in price times the price at any given point. This change in quantity over change in price is the slope of the demand function. And slope, by definition, is the change in one variable with respect to another variable. And in this case, the change in quantity with respect to price is constant, and therefore this is a linear function. So this form would be a linear functional form of the demand curve. How do we get Ashley's demand in linear functional form? Well, we start out with our two variables, quantity and price. We say that quantity is dependent upon price because price is the thing that changes, and the quantity that Ashley purchased is the thing that we observe as a result of the change. So quantity is what we might call the dependent variable in this system. Dependent. It depends upon the price at the given time. When the price is $0, we know that Ashley would take 1,000 widgets. And so for Ashley, the constant term for the linear demand function is going to be 1,000 units, because that is the quantity that occurs when the price is 0. Because of the law of demand, the actual linear functional form for a demand curve is typically going to be a constant followed by a negative sign, because the negative represents the negative relationship between the change in quantity and the change in price. They move in opposite directions. Price goes down, quantity goes up. Price goes up, and quantity goes down. Our function then becomes quantity is equal to 1,000 minus the change in Q over the change in P. So the change in quantity over change in price is 200 over 400. And of course, for the linear function, we have to multiply that by price. Price is what we would call the independent variable. It is the variable that's outside Ashley's control. So what we observe as economists is there's some price change, and we observe how Ashley reacts to that price change by changing the quantity that she wants to purchase. Okay, so we have our linear equation for Ashley's demand function. It is Q is equal to 1,000 minus 200 over 400 times P. So if we go one more step and we simplify this, we can find Ashley's linear demand function is Q is equal to 1,000 minus 1/2 P. Now let's graph Ashley's demand function. When you know the linear demand equation, it's actually very easy to graph this equation. All you need to know are the quantity intercept and the price intercept. Oh, and one other thing. In economics, we do a very strange thing. We actually don't graph the demand equation. What we do graph is what we call the inverse demand equation. And the reason we do that is because when we have supply we want to be able to put those two together and create an equilibrium where we look at quantity and price in a slightly different light. So we want to get used to graphing the inverse demand function. Well, to graph the inverse demand function, we should probably figure out what that inverse demand function is. It's actually very simple to find. All the inverse demand function means is if this is your demand function, it's written as Q is some function, some linear functional form of price. Well, for the inverse demand function, we want to find price as some function of quantity. We're going to look at the same equation in a slightly different form. So to get it in this form, all we need to do is solve this equation for price on the left-hand side and put Q on the right-hand side. So let's combine some steps here, and I'm going to put 1/2 P on the left-hand side is equal to 1,000 minus Q on the right-hand side. So I subtracted Q from both sides and added 1/2 P to both sides. I want P isolated, so I'm going to multiply both sides by 2, and I get P is equal to 2,000 minus 2Q. This is the inverse demand function. And this is the function that we're going to graph. Now, again, this is actually the exact same equation as our demand equation. It's just written in a different way. Okay, so let's graph our inverse demand function. So the things we need to know, very simply, if we know the p-intercept and the q-intercept, then we can easily graph this function. So how do we get the p-intercept? The p-intercept is the price that occurs when Ashley wants 0 units. Okay, so the p-intercept is going to be the price that occurs at that price that puts her out of the market. To get the p-intercept, let's substitute 0 in for q, because by definition the p-intercept is the place where this function crosses the p-axis, and we know that that happens when q is equal to 0. So let's write our function here. P is equal to 2,000 minus 2 times a q of 0, so we'll put in 0, and this becomes just 2,000. So our p-intercept would be $2,000. So I'll write a point here. This is the point 0, 2,000. That's our p-intercept. Now our q-intercept is the point at which the demand function crosses the q-axis, and we know that happens when p is equal to 0, the price is equal to 0. So back to Ashley's problem, the q-intercept would be the quantity she wants if we're just giving the product away. So to find that, let's substitute 0 in for price. And I can substitute 0 in for price in either my demand or my inverse demand function, and I'll still get the same value of Q because they're really still the same equations. Okay, so let's go ahead and substitute it into the inverse demand function. So I have P is equal to 2,000 minus 2Q. So if P is equal to 0, 0 is equal to 2,000 minus 2Q, or 2Q is equal to 2,000, and Q is equal to 2,000 over 2, or 1,000 units. So here's Ashley's q-intercept. It is 1,000, 0. Connecting these 2 points with a line, we get Ashley's inverse demand curve. One thing to note is when you're looking at an inverse demand curve, the slope is no longer the change in quantity over the change in price. The slope is now the rise, or the change in price, over the run, which is the change in quantity, or change in quantity demanded. So for the inverse demand curve, the slope is the change in price over the change in quantity demanded.